All righty, I'm ready if you're ready. You guys ready? Yay. I recognize a lot of faces here anyway, so let me do the bio really quickly. My name is Richard Campbell. I wrote my first line of code in 1977. That is not the most important thing that happened in 1977. The most important thing that happened in 1977 was Star Wars. So let's focus on what's actually important. And I just heard that Rob Howard is taking over the new Han Solo film, and I'm not sure what that means, but I'm glad they're making new films. Of course, that computer in 1977 was a TRS-80 Model 1. It had a whole 4K of RAM and a cassette tape player, and that was an RCA TV modified to be a monitor, which probably gave me these. There was a version of BASIC on this that fit in that 4K that was not written by Microsoft. It was actually a tiny BASIC, and it only had 3 error messages. What? How? And sorry. Being the most Canadian of error messages, of course, because I'm actually a Canadian. I've done a lot of different things over those years. These days, one of the things I do is I make conferences. I did one last year called Dev Intersection in Harlem. This year in September, we'll be in Sweden, in Stockholm. So if you want to hang out with us, that's a show we're doing. And if you'd rather go to the United States, this fall, at the end of October, at the MGM Grand in Las Vegas, we usually get a pretty strong lineup. There'll be a couple of thousand people there. Besides that, I make a few podcasts. Any .NET Rocks listeners? Awesome. So a few folks in the room. My friend Carl Franklin started .NET Rocks back in 2002, which is a couple of years before the word podcast even existed. I'm the new guy. I came on board in 2005 at Show 100, and we yesterday published episode 1452. So yeah, a few episodes. And a lot of what I'm going to talk about comes from talking to all these smart guys and girls over the years about software development. I also make an IT podcast, which I've done for 10 years, called Run As Radio. And for a few years, from 2011 to 2014, we made a separate show called The Tablet Show, until it became apparent that tablet development was just development, and then we rolled it into .NET Rocks. I'm also heavily involved with Humanitarian Toolbox. We're making open source software for disaster relief organizations. I have been working with some folks in the Netherlands on this. We have a bunch of different projects underway. If you're interested in donating your coding skills to charity, we can make it easier for you to do that. Like I said, we focus on disaster response because those guys can really use more code. And that's htbox.org. So let's get to this. We've got about an hour, and we'll start with a conversation about the personal computer, which of course is not very cool anymore, even though it bought me a house, maybe more than one. This is the current set of charts around PC sales. And so we sort of peaked in 2011, and it's been declining ever since. The last numbers are from 2016, obviously 2017 not finished yet, although they're saying 2017 is a better year for the PC than it's been. And of course, one of the indicators here, the iPad shipped in 2010. So one would argue that the age of the tablet really came along in 2010 and took a big chunk out of the PC market. Although it bothers me that they consider this a personal computer and this is not a personal computer. Because what's more personal than a computer you keep in your pocket? A computer you're afraid will give you cancer. Like, that's a pretty personal computer. I keep it in my pocket and I wear a Bluetooth headset so I can get brain cancer, testicular cancer at the same time. So, yeah, funny, we sort of changed the terms. Now we talk about being smartphones, but they're still really quite personal computers. Like, in that sense, not much has changed. And then what's really happened is that computing power has gotten denser and denser and denser. And a good comparison is to look at something like this. Anybody recognize this? Warp core from a starship? No, that's this. Now, this is a Cray XMP computer circa 1985. This was arguably the most powerful computer in the world at the time. Cost about $16 million, that's 1985 dollars. Cooled with a chlorofluorocarbon, a liquid, because in air it would just burn up. 200 kilowatts power consumption, so no batteries. That's not going to work out for you. 1.9 gigaflops of computing power. Okay, so at the time, in 85, 1.9 gigaflops, they modeled nuclear explosions off of this, jet engine airflows. These were very expensive, important computers of the day. Compare that to the iPad 2, also 1.9 gigaflops. If you submerge this in liquid, you will void your warranty. 25 watt-hour battery, which is good for a couple of days if you're careful with it. And pretty much the only thing we do with this is play Candy Crush. So yeah, not exactly the same computing cloud. But you know what the point is? The point here is what was the fastest computer in the world in 1985, in 2011, kind of a run-of-the-mill tablet. And it's not that fast. If you really want to talk fast, you talk about things like the Titan X. Like if you have an urge to drop 1,000 euros on a video card, we can help you. Okay? This thing's madness. You're now talking 7 teraflops of processing power, right? So that's 3,500 times faster than the iPad. Also 3,500 times faster than the most powerful supercomputer from 1985. And it's $1,000, and it's not even a whole computer. That's just a card. You can put 6 of these in a machine if you really want to. You also could cook food on that machine if you do that. Used to be the fastest supercomputer in the world. This is a couple of years old now. This is a Chinese computer. It's now a new Chinese computer. It's the fastest one. This is that Tahoo Lite. $275 million, 93 petaflops of compute. Basically needs its own nuclear reactor to run. 15,000 times faster than the Titan X card I just showed you. Yeah. So now we're talking, they figure that the human brain runs roughly 25 petaflops. So this is almost 4 times more horsepower than that. This is silly, silly amounts of compute. And the race continues. But like the iPad, also made in China. And the point is that we've had this Moore's Law effect for a while. We've been moving along denser and denser and denser technology. But the more important thing here is that we're not done. Like Moore's Law is starting to struggle. There's no two ways about it. Intel's starting to struggle now. The real issue we're getting down to is they're talking about transistor sizes where the number of atoms matters. You know, they're now making 11 nanometer circuits. 11 nanometers sounds big, kinda. When you consider that a silicon atom is 0.1 nanometers across, it's 112 picometers across. They're now trying to put a transistor in a space where it's only a handful of silicon atoms, and that's a problem that, you know, quantum effects and things start to matter. So we're going to run into a wall in that respect in the next few years, but the density of compute is so high that we're now, what we used to call a personal computer, able to put them in so many different form factors. You know, the defining part of the form factor around our phone today is not the compute, it's not the horsepower, it's the screen and the battery. Right? You take those 2 things away, and this is suddenly down to the size of a thumbnail. But for us as developers, the challenging part here is that the software that we're building and the machine that we're building on is not the device that our customers are using. It used to be, for a long time as software developers, the computer we were working from, keyboard, mouse, screen, was the same computer that our users were going to use. We may have had a slightly different configuration, maybe a bit more memory, a bit more screen space because of our dev tools, but for the most part, you could write the code, run the code, look at the code, and have a pretty good impression of what your user was going to see. And that's simply not true anymore. The vast majority of consumers, if you're doing consumer-facing stuff, are seeing your software through one of these. And I've done many things on a smartphone, but writing code is not one of them. So suddenly we have this much broader loop in our lives in terms of how we write and test, explore software. We've gotten really good at that, write a little, run a little, write a little, run a little, except that that cadence is much slower when you introduce these other devices. And so when I'm looking at the productivity of a team now, I'm much more concerned with how do we still feel like the user, still reach out onto those devices, but keep that loop tight, be able to get around it fast. And it's things like emulators and any trick and tool that I've seen that allows us to keep that cycle fast so that you can still iterate, you can still explore your code and add to it, knowing that you're still looking more or less at what the user can see. And I even admit that even in the PC days, there was still a point, while we may have been iterating with our own machine, but at some point you really did have to take a cut of the software and run it on your customers' machines that typically had less memory and a more latent connection and a lower resolution screen. It's just more extreme today with these devices. And it makes it kind of pine for the good old days, really, right? Go all the way back to those Brady Bunch days where while we had diversity, the choice was really Windows 98 or Windows 2000. Of course I did, because these were beautiful days, right? But I would also argue that these were also anomalous days. There was a period, and a lot of folks that got involved in development fell into this period, where everything was Windows. And so we built for essentially one operating system with maybe a couple of variations. There wasn't a lot of choice there. But if you go far enough back, before this period, there was a time when PCs were wildly diverse. The Apple II, the Commodore 64, the good old Mac, the IBM PC, they all ran different operating systems. So if you go back far enough, you go back into the 80s and the early 90s, we had the similar kinds of problems of dealing with a diversity of devices. And so when I look at this, it doesn't seem all that much different than this. That now we have a diversity of devices again, whether they're laptops or they're tablets or they're phones or they're really big obnoxious phones. There's this diversity problem. And developers always want the same thing. We want to write the code once and have it run everywhere. It's a very reasonable thing. It's not something our customers care about at all. They just want it to work on their device. But we want to write it once and run it everywhere. And I'm here to say this is a mantra that's gone on for a long time. So let me tell you a version of that mantra from back in the 80s with a product called MultiPlan. Now, a few things to notice about this box. This is the oldest one I could find. First off, it's for the Mac. Second off, it's $325 US. Boy, that's pretty optimistic, isn't it? But PCs were more expensive back then. So if you haven't heard of MultiPlan, you're not alone. MultiPlan was a spreadsheet product made by Microsoft in the era of the pre-IBM PC dominance period, and really before Windows and things came down to pass. There was a brilliant, brilliant man that worked at Microsoft by his name. His name is Charles Simones. He's a Hungarian computer science developer. He's the person responsible for the term Hungarian notation. That's how long ago we're talking. And Simones had a vision of doing cross-platform development with one of the original cross-platform languages, C++. And so his idea was there was a model you developed in, and then he could cross-compile for the IBM PC, for the Atari ST, for the Amiga, and for the Mac. And so MultiPlan was a spreadsheet product for all of those platforms. And the result was a spreadsheet program that ran equally slow on all of them. And a competitor appeared. Anybody remember the name of the competitor? Lotus 1-2-3. And Lotus 1-2-3 ran on one platform only, the IBM PC. And it was tuned for the IBM PC, and it was fast on the IBM PC. And a lot of people bought IBM PCs to run Lotus 1-2-3. And MultiPlan was kind of relegated to the dustbin. We paid such a high price for being cross-platform that a competitor came in, optimized for a particular device. People bought that device to get to that product, and that won. Now, this code didn't completely vanish. It resurfaced in a new product when Windows World came along called Excel. And oddly enough, much more optimized. In fact, it even implemented bugs that were introduced by Lotus 1-2-3, like not doing dates correctly. So,
which version of Excel is this?
that is Excel for Windows 2. Woo, yes. And notice that you have an application called Clipboard, because back then, that was a big deal. That I'm actually going to take data from one application and put it in another application. That was crazy talk in the era. And I bring up the story primarily to introduce you to the idea that this heterogeneous client world we have is not that anomalous. We have been here before. One would argue that the Wintel hegemon of the late 90s, early aughts, that was the anomaly. This is far more normal, that we have many different kinds of clients for many different kinds of users, and our development scenarios are complicated. We have to figure this out. So we've tried it before, right? I mean, Java was another approach to one language, many platforms. Obviously, that mantra changed over time. And just to bring a little pain into the room, let's remember Silverlight. Silverlight was an early attempt by Microsoft to solve cross-platform problems. They built a version of the CLR that ran on the Mac. They don't talk about that much anymore, but that was the truth. That you could actually write in C# and XAML, compile it, deploy it to a Mac, and it ran. Now, there were other things that went wrong here, right? Lots of folks had the experience with Java, which was write once, debug everywhere. And Silverlight ran smack into the wall of when Jobs decided that Flash was not going to run on the iPad, which was a logical decision for Jobs, right? To say, hey, if I run this on the iPad, all I'm going to do is drain my battery. So no Flash, which means no plugins, which means no Silverlight. And suddenly, that cross-platform solution sort of got punched in the head. Let's talk about that. But first, if you talk about the real cross-platform tools, you probably talk about HTML and CSS. Right? Everybody's got a browser. Everybody gets along with the common set of specifications, so everything works just fine, right? Except, of course, unless you have Safari. If you're serious about web development, you've now bumped into what people are calling the new IE6. Now, that might be a little unfair, but let's talk about why was IE6 IE6? Well, IE6 came out in 2001, even before XP shipped. And it was developed before CSS1 was even a ratified standard. And it came with XP, which was the operating system of choice for 5 years until Vista shipped. And then it was still the operating system of choice until Windows 7 shipped. And so IE6 was around for a long time. And the basic measure here is popular and not compliant with standards. And now that IE6 has finally been shuffled off into the grave it deserves, we're dealing with another browser that is popular and not compliant with standards. And it's Safari. And it's iPads. Now, you can get Chrome for the iPad, but we're back to that same problem. And I find I'm talking to developers on a regular basis now where they build a proper HTML5 app and a version for Safari, just like we used to do for IE6. And at some point, maybe we'll have a revolt. I don't know. Now, the challenge, of course, is dealing with the diversity of devices. And that leads to this, by the way, the greatest mug in the world. Everyone needs I love my .NET Rocks mug, but this mug just makes me happy in so many ways. So, responsive web design, right? This incredibly challenging thing to do to say, how do I compose a page with behaviors depending on the size of the screen and its capabilities? And there's more to responsive web design than that, but it's sort of the essence and the challenge that they're in. And the main thing that you come down to is this challenge of testing. How do you know that it works? And so you iterate through different devices. And we had a story on .NET Rocks many years ago about this concept called the drawer of broken dreams. So let's go through the process when we're doing mobile development, right? You pull out the popular phone du jour. Perhaps that is the Samsung S8. And you make your page render beautifully on the S8. Then you take the next most popular phone, a Pixel S6P, and it doesn't render quite right. So you twiddle with your CSS a bit, you get it to render nicely, now you regression test back to the Samsung, it's not quite right. You go back and forth between the two for a little while until you get a nice rendering on both, and then you go back to the drawer of broken dreams. How many phones are in the drawer of broken dreams? Well, if you want to get to about 80% of the Android market, it's roughly 100. Have fun. Now, there's now cloud test libraries and better tools for us to do this a little less painfully. But the bottom line is variation in devices is always going to be something that haunts us. And that's just talking about public-facing modern stuff. If you're dealing with an enterprise, you may have some fairly archaic devices floating around. It may be a smaller set of them, but again, it becomes a challenge to do development that's actually consistent across devices. And that's to be talking on the web side, but you could also talk about on the native side as well. There's a Carl Franklin gag in here because you may be talking about Objective-C and C and Java, but that's actually the core C#. So that's what we're talking about. Now the challenge on true, proper native development. So we're writing an Objective-C, we're writing a Java sources. You end up with these are different skills. Really rare to find any individual that can do this symmetrically. So you end up with multiple teams. It's just too much money and too costly. It causes a lot of problems because you end up iterating the apps at different times. So how do you maintain the back ends? You make customers angry because the iOS guys got an update, but the Android guys didn't. And that can come down to the app stores. There's just a lot of pain and agony in here. If you've run across this, you're well aware of it. And yeah, the relevance of C# is questionable, unless you talk about Xamarin. So one would argue that Miguel Diaz-Casa carried the torch for C# even when Microsoft was not carrying the torch for C# particularly well. And he did come up with a set of tools that allowed us to write in one language and more or less build apps for both iOS and Android. And that now as they've been acquired to Microsoft, is getting smoother. We're seeing things like the XAML standard where they're actually trying to standardize all of the elements here. You are compiling to native. They're remarkably good at absorbing the variations in the platforms. So one of the biggest things I've seen in hybrid development strategies, and this is only one, is that you'll get more phones off the bat for a given build of your application. And if C#'s not your bag, you can do JavaScript against Cordova. Of course, now you're involved with Adobe, which is going to create your own sense of pain. A sign of the instability in this space is the sheer diversity of tools that are available for it. Microsoft makes one. Other companies make them. There's a ton. And I'd be utterly remiss if I did not mention Delphi in this scenario, because they've been solving this problem with a version of Pascal since 2011. So, you know, there's a lot of clout there, right? There's more than one way to solve this problem, building abstraction layers that run against the devices. And again, Moore's Law is working in our favor. If you only dabbled with cross-platform development on mobile devices in like 2011, 2012, devices were much weaker back then, and the hit you took to be able to run those common communication layers was much more expensive than it is today. These days, our phones are as bored and lazy as our web servers. The CPUs are mostly sitting around smoking cigarettes and playing poker, waiting for you to click on something. We can afford to waste a bit of horsepower to make more maintainable code. So whether you like to live in Delphi, or you like to live in JavaScript, or you want to live in C#, there is tooling across the board to try and do this. And that's still not the whole stack, because we're playing with other ways to build web pages. So we've talked a lot lately on the show about this whole single page application model. And AngularJS, which is the 1.0 edition, or you have the Angular, which is 2, 3, or 4, depending on what day of the week it is. Google's poured a ton of money into this. Lots of people are using it. You can even find people now saying they have 10 years of experience in Angular, which is amazing to me. Our good friend Rob Eisenberg, who currently is with Microsoft, who joined and worked with the Angular. He made a product called Durandal for a while in open source. Then he saw that Durandal and Angular head in the same direction, so he worked with Google for a while, working on that. And then he was unhappy with the direction that Google went with Angular, spun off, and somehow spit out this other framework called Aralia. If you've never looked at it, it's astonishing. The conversations I'm having these days with folks that are using that tool is, while I make money on Angular, my love is in Aralia. So if you really care about the single page application model, it's well worth your time to look at that as a tool. This is a library, and it takes time to learn it. It's not a small bar to jump over. And not every application makes sense as a SPA. You know, email makes sense as a SPA, but if you're building email, stop it. It's been done, right? Build other things. Some apps make sense in that model, especially real-time apps or apps with steadily updating data. And I mentioned SignalR in that context because this is one of those many examples of how we're turning the browser into more of a smart client, that we're actually able to connect it to a server that's going to steadily feed us data. And SignalR is very clever about hiding all that WebSocket technology and making it work for every browser. Because each browser implements sockets a little bit differently, unless you're dealing with Safari, in which case it doesn't implement at all, and SignalR falls back to a polling solution, because SignalR is good software, Safari bad. And I should mention progressive web apps in that context as well, because this seems to be the ultimate manifestation of web development. Now we're actually talking in terms of manifests, talking about offline service agents, being able to manage a lack of connectivity, local stores, queuing and caching, you know, bit by bit. And the challenge, of course, is the Chrome team and the Edge team, right? This is really the V8 team and the Chakra team. These are the underlying engines, are collaborating, going back and forth and challenging each other to implement these features, put them out in the field for people to test and experiment with. It's been really kind of exciting in terms of how good of an app could we make, and how could we make a really palatable app even on a mobile device and not have to deal with an app store. So I think a lot of the energy around this has been recognizing that app stores are now cesspools of scum and villainy and really, really bad software, and a 30% margin to Apple. Can we just build the software the way we want, distribute it the way we want, get rid of those extra hoops, update it the way we want, be more tolerant to iOS changes, right, in this abstraction, because we have enough horsepower and the browser is sophisticated enough. So Well worth an area to take a look at if you spend some time in web development and you want to go further with it. Obviously, the challenge always is dealing with browsers that aren't compliant, and we're still looking at Safari when we complain about that. And I'd be remiss if we didn't talk a little bit about the Windows client side. Again, Delphi has been doing good Windows clients for a very long time. I'm stunned at how many folks we talk to that are still using the WinForms library because it works, and their customers know how to use it. They're happy with it. WPF got off to a very rough start more than 10 years ago now. It's in better shape than it's ever been, but the tooling is continuing to evolve, and deployment's always a challenge. It gets very addictive when you're dealing with a web world where you always have a current version of the client, never have to maintain an older client. But we've got better mechanisms now to push those updates steadily. I mean, that was one of the strengths with Silverlight, is that we're able to do all of those things. But yeah, this is still a huge chunk of development today and very productive, and you're still seeing new pieces being done in it. I should talk a little bit about Windows 10 because Windows 10 broke the model in the way that Microsoft saw Windows. Windows is no longer Microsoft's principal product. I mean, that's a fairly big deal, especially if you've been in development for a while, where it was, when .NET came out, it was 22 languages, one platform. And that is not .NET today. .NET today is several languages, C# being predominant among them, but VB.NET and F# still doing just fine. And you can buy a current version of COBOL.NET if you want. Fujitsu still ships it. It's a product. Against this runtime that then handles a diversity of backends. And the backends are actually only getting more diverse. We should see a resurgence in ARM in the near future. And .NET's simply going to absorb that for us. But in the Windows 10 context, we also abandoned IE for Edge. Edge has improved. It's been, because it couldn't be much worse. Is the way it came out in the first place. A little too locked down, a little too hostile. Win 10 also brought Cortana to the forefront. So we're starting to now see hardware working really well with Cortana, where this conversational interface is a reasonable thing for us to do. Obviously, Apple with Siri, Google's voice products, and Amazon's Echo device, these are all interesting devices in the context of what we're calling ambient computing. I'm excited about Cortana and the back-end services because, once again, Microsoft approaches this from a dev perspective. And so it's easier for us to look at that from a development exercise. If you try and get into the APIs over on the Amazon side, it's challenging. We take for granted, working with organizations like Microsoft and like Embarcadero, that they get devs. Then you go work with I think Apple's basically hostile to dev. You're sort of a necessary evil. And Amazon's just baffled by them. Why would you want that? And so you have a bunch, not that you can't get it done, it's just a bunch of hoops you're going to have to jump through, stuff that in the ecosystem you're currently living in, you're going to struggle with. This concept of the universal app has gone around a few times. Microsoft's latest incarnation, not too shabby. They are including a larger spectrum of devices. Still not really talking about iOS and Android in this context yet, but they have looped in this thing, which everybody's really, really excited about. The HoloLens is very cool. It's $3,000 US. You can buy one if you want. The hardware is now 3 years old, so we're kind of overdue for a hardware refresh. Supposedly there was a HoloLens 2 that they decided not to release this year because there was some third-party gear coming out. We saw this in Build with the Acer and the HP gear, which we should have this winter. And supposedly there'll be a HoloLens 3 out in late 2018. So I think about what will displace the smartphone as the digital extension to a human. So everybody's a cyborg now, because we all have a digital extension to ourselves. Now, this is a very geeky crowd, so of course we have this. Had it for a long time, had it in lots of different forms, don't think it's a big deal. But when average mortals now freak out because they've misplaced their phone, the same way if they misplaced a hand, you get an idea of how important our digital extension is to ourselves. But this device pretty much stopped evolving after about 2007. iPhone was the end of the road for the smartphone. Smartphones were a lot more interesting before that, with different keyboards and configurations and form factors, but it eventually all became a slab of flat glass. And we may have tweaked and twiddled with it for the past 10 years, but it's all been a slab of flat glass. What comes next? Because if you're thinking about what you want to do as a developer going forward, what the opportunity space is, you got to think a little bit about what comes next. And so I think this is a very interesting area. I think it's really only two areas that seem to matter. The ambient computing, where it's just going to be present, probably voice-driven, or the visor approach, where you're going to put it on your face, it's going to put stuff into your eyes. And both have possibilities. I think this provides ambient computing anywhere. It's ambient because it's already on your face. You're going to have it around you all the time. Everything's effectively a screen. Program against it, of course, is its own set of challenges. I could make a little mention of wearables, just from the context that, yes, they exist. Everybody's trying to figure out if this does anything useful yet. I have a few folks now talking about being happy with their iWatches, which I think has more to do with setting expectations than actual functionality. I wore a Band 2 right up until this trip when it failed me, and now I can't replace it. I have to send it back, and they will give me money. But what's interesting in the wearables context is not an extended screen. It's really the instrumentation of the body. So continuously being able to measure how far you move, where you go, what your physical status is. This is a growth marketplace. Everybody's interested in it. And being able to feed that data into an overall system is very interesting. And that does sit on top of this concept of the Internet of Things, right? Or you can call it the Internet of Crap if that makes you happy, because there's plenty of that. You know, I don't need an IP address in my toothbrush. Stop it. It's unnecessary. But we're already well underway to 4 IPs per person on this planet, which is one of the reasons why IPv6 is kind of important, because there's not enough IPs in IPv4 to make all of that come true. And we get back to that core concept of Moore's Law is making these devices smaller and smaller. Got a Raspberry Pi 3 sitting right here, effectively a PC the size of a deck of cards. And again, down to thumbnail size, being able to put them in almost anything, meaning we have compute everywhere. Many, many different devices all being able to do specialized things and feed them back to us. And so the Internet of Things represents just this increasing plethora of development. A funny thing happened along the way. General compute became cheaper than specialized compute. I mean, for a long time in our appliances, we've had computers of various kinds, but they were optimized for cost, the minimum amount of compute necessary to do the particular task. But when you realize that a Raspberry Pi is coming in under $50, under $20, under $10, suddenly this thing that actually will run a standard development library is cheaper than the embedded stuff. It's also cheaper to develop on because there's a lot more developers. And so you're starting to see appliance makers wanting to use off-the-shelf compute hardware, which means, yeah, I've got a web server in my dishwasher. I'm not saying it's a good idea, just saying it's there. Now what happens? And so our development skills suddenly become more and more valuable across a broader and broader reach of devices if we can think well about how those things work together. And the one thing you need to think about the most is security. Because if everything has an IP address, everything has a hacking template. And it's all that much more challenging to work with it. And I don't believe in the Ludditism. I'm not going to go back. I can only go forward. We just have to get better at this. There's no two ways around it. And it's going to be everywhere. But I'm not worried about our careers. Lots of other people are worried about careers. They're putting more computers into everything, guys. We've got more work to do than ever. On the back end, a couple of things I want to talk about. I mentioned IIS and Apache in the same voice as the most common back-end libraries out there, and generally mutually reviled, and almost for exactly the same reason. These were Swiss Army knife type back-end tools back in their day, which is to say they did everything and everything was on by default. The name Apache Server is not about the First Nations group. It's about the fact that when they started making it, it needed updates all the time. It was literally a Apache server. That's where the name comes from. I couldn't make this up. I'm not that funny. But that's where it comes from. And so they suffer from exactly the same issues, that they have so many things in them, and they're on by default. You don't know what they are. And so they have a huge attack surface. Right? They represent problems in terms of debugging, in terms of securing. It's complex. And the counterpoint to that is to turn everything off by default. And that's when you start seeing, like, Node.js is the opposite of Apache and IIS, that says everything is off. What do you want? Now, first off, what's interesting about Node.js is one of the best examples of what happened when Chrome and IE when the V8 team and the Chakra team started dueling back and forth for the best browser. The consequence of that was building an extraordinarily good JavaScript engine. And the V8 team provided that engine to the Node guys that ended up building, hey, we can run JavaScript completely in a different context. And by the way, if you've never spent some time in Node, it's the least loathsome JavaScript you've ever seen because it's server JavaScript. So it's kind of clean and lean. You're not dealing with all that ugliness. The HTML and CSS, nowhere to be found, which turns out they're actually the enemy. Right? JavaScript is a pretty nice language today. Now, it's still sort of functional and dynamic, so writing reliable code means a lot more testing, a lot more harnessing, but it can be done. If you like your statically typed ways to go, there are ways to stay in your static, I have no complaints about C#. It's a productive language. You're just asking the compiler to do more of the work. But philosophically, Node went completely the opposite way of those earlier technologies for server side. WinAPI and on the Microsoft side, very similar mindset, just the pieces you need. There are other frameworks, Akka for Java and for .NET. Erlang, if you want to make a complete break. Now, what's interesting about these approaches, these actor model approaches, is parallel by default. That your code, your values are immutable by default. So you can run things. You have to manage state separately. You have no choice. They force you to make correct decisions. And the side effect of that is that as the number of instances increases, it's stunningly effective. Erlang, not a super fun language to develop in. It comes out of Ericsson in the first place. Very much a telecom language. Was still to this day runs an awful lot of telecom infrastructure, but you can scale amazingly. This is what WhatsApp was built on. And if you don't want it, it's as much a language as an operating system. The jump to Erlang is non-trivial. But if you've got a seriously challenging scaling service problem, it's a very interesting way to look at it. The bridge between these things is something like Akka, is an actor model library, which again has these constructs that are very tolerant to scale, but you still work in the language that makes you happy. So it's a way to, an ability to explore that in a way that's not quite so painful. And there's also tools like Elixir, which is dressing on top of Erlang to make the syntax of the language a little friendlier to work in, not as painful as it has been in the past. The other back-end services, these started out on their own, but they're really doing well in the cloud context. I have nothing bad to say about SQL Server. SQL Server made me an awful lot of money. It's a good product. It's still around for a reason. It scales well enough in many scenarios, but there are scenarios where it doesn't make sense, especially when you're dealing with data that's not particularly relational. The MongoDBs and document stores of the world made their surged up because the developers could manage them. There's a basic concept here. It says, I'm constructing objects off of a web page that represent the order of the customer. Why, when they say place order, do I make them wait while I decompose those objects into rows and columns and write them into a database? Why don't I just store the objects and send them on their way? So you stash that data in Mongo, let the customer go on its way, and then offline, independent of that transaction, you can decompose those objects into rows and columns so you can still do your reporting. But getting rid of synchronous behavior across those things just allows you to scale better. And same with services like Elasticsearch, just admitting that I need a nearly correct copy, close as possible, so maintain a copy there, but we can query it faster. There's an awful lot of thinking that's gone into how we store stuff and retrieve it fast. Just don't presume that there's one right way for all of those things. The cloud has also had another big impact when it comes to doing data analytics. You have this idea called a data lake, which is, now in the old days we had data warehouses. And data warehouses were really about, let's decompose the data and order it for high performance querying. Because we have a limited amount of compute resource. If we don't optimize it, the queries will take too long, people won't value them, they don't understand them, they can't follow that intuition to learn stuff about data. The cloud largely makes that concept obsolete. It says, hey, you need more compute? I got more compute. It's on a knob that goes to 11. Just turn it up as high as you need to, and you can compute harder. And so data lakes really are about taking all that data and storing it en masse so that you're able to query it any way you want. And that led us to these concepts around big data where we were simply decomposing the data, mapping it out into multiple computing resources so that we could do a huge amount of compute and then reduce it back down again. Now, even Hadoop is a fairly arcane concept compared to what we're doing today. I used to do, 10 years ago, to do analysis on huge amounts of terabytes of log data. Today, again, with the cloud, you have all of these different systems for doing learning that allow you to not be efficient. You know, once upon a time, utilizing a machine learning algorithm or a data mining algorithm meant a lot of planning because the constraint was compute. Now that we don't have that constraint, try every machine learning technique. Do all the data mining algorithms and then compare them. You've got enough compute. Now, machine learning is a really hot term. It represents a lot of different things. I break them down into several different categories. One of them is predictive analytics, which is the subset. Predictive analytics is something that the average business user gets their head around. You sold this much last October, how much are you going to sell this October? You know, you can compare period to period. Those kinds of analysis helps, and you can account for additional stores, additional mechanisms. So PA is a subset of that. Machine learning is the broader one where we can do a lot more discovery. And again, the cloud helps us tremendously with dealing with the diversity of that kind of data. And I'm going to loop back on machine learning in a little bit. I want to talk about a couple other technologies, and then we'll come into a wrap here. I'd be remiss if I didn't talk a little bit about containers from the point of view of this is a new way to encapsulate functionality in your software. It's a derivation of virtualization, which we've had around for a long time. The challenge of virtualization is because your whole operating systems around, it's just so big. They're inefficient, they're wasteful, they're not easy to move around. Really, in most respects, a container is your application living in a operating system context that it can't really touch or affect, but neither can it touch anything else. So you've essentially made virtualization with the operating system out and configuration as code as the default. You know, in the early days of virtualization, it was really about testing. Performance wasn't a huge thing there. You know, first incarnations were back when we were dealing with DLL hell. You wanted to experiment with all the different configurations and how you would install your app, and virtualization made that easy because you'd make a snapshot before you'd install the app, you'd install it, it would break, you would roll it back, you'd tweak the configuration, you'd install again, until you made them all work. Speed wasn't of the essence. Then the IT guys got their hands on virtualization because it could allow them to utilize hardware more efficiently. Now, like I'm running 2 or 3 servers inside one piece of hardware, I condense the data center down. Now speed is of the essence, and so a lot of virtualization poured into speed. But size wasn't a big deal because we've got lots of disk space and we don't really care. Containerization is, to my mind, the next iteration on this concept. It says, let's make the containers small. Let's make them specialized. Instead of having one master service, the do-everything service, where when you update it, it breaks everything, we decompose those services, this microservice concept, into little pieces. We put them in containers so we can scale them independently, can test them independently, can kill them independently, can build new instances independently, can update versions independently. You end up with lots of them, which means you have, this represents a new class of management problems, but those are for IT people. We'll let them suffer. And there's tooling to try and make that easier. Microsoft's approach in Azure is this thing called Service Fabric, which allows us to absorb a bunch of this. It's the only standard Microsoft slide with lots of stuff on it I'm going to use, for better or worse. But it's important in the sense that you can run it on third-party clouds, you can run it on Azure, which they prefer you to do, or you can run it on premise. But all it is a set of tools for managing your services, whether you put them in containers or not. We could have a whole conversation now about serverless, right? Which is the Azure functions or the AWS Lambdas of the world, or Firebase for that matter, where it's just like, hey, run the code. Don't worry about the plumbing at all. Plumbing is completely gone. Just run the code. And when another person calls it, run it there too. And again, and again, and again. And these are all constructs, like those actor models, that basically force us to think about how do I manage state, and how do I keep each of these independent pieces of code functional on their own so they can be run in any combination, which allows us to scale very well. What I like about the cloud is the architecture more than other people's computers. This architectural model makes me more efficient on-premise as well as in third-party hosted environments. Whether that be public cloud, private cloud, it doesn't really matter. It's an architectural approach to being able to scale and tolerate change extremely well. You strip away as much plumbing as possible. And I've got one last theme. which we really saw come up this spring, and I think is huge for the next couple of years for us. When you take the huge amount of storage that's now available to us in the public cloud, and the huge amount of compute that's available, the new machine learning systems that are available, we're now talking about artificial intelligence again. And so there's no way to say this other than we know that AI is coming. Now, I'm not worried about how. All right, I don't think artificial generalizing, we haven't been able to find consciousness for ourselves. It's going to be tough to write the code. But what I am worried about is we now have machine learning, huge amounts of data, huge amounts of compute. And at Build, we saw a stunning demo. So this was cameras scattered over a construction site, watching everyone move around that construction site, identifying tools on that construction site, and identifying unsafe conditions. What I found interesting about Microsoft doing this is that normally at Build, Microsoft shows you an amazing example and then says, and here's an SDK. They did not do that this time. What they talked about is this being a challenge that's upcoming for us in the context of this is what we're going to be capable of doing, that we should be able to, with a reasonable amount of software, be able to track every person, every important object, and they put it very much in the context of safety, which I appreciated, right? They had an example of somebody resting a jackhammer up on a wall. It's like, that's dangerous, lay it down on the ground. Or when a forklift brushed against a barrel of chemicals and that barrel tipped over and spilled, it was the vision system that identified the spill, knew what it was, evacuated people, and told the right people how to go in and how to clean it up. The challenge here, and I'm sure you had this same experience, I had it when I watched it, is this concept called the uncanny valley. They usually apply this to robots, but I want to apply it to AI, which is to say, you're cool with it, you're cool with it, you're cool with it, you're cool with it, holy crap, you drop into this horrible, like, that is dystopia kind of moment. Right? And in robots, they talk about dropping in the uncanny valley where they make robots that are more and more humanoid until they're human enough that something in your lizard brain goes, that's not right. And I feel like we're kind of there with software right now. We're really being challenged to think comfortably about software. And I think it's a big enough deal to make a comparison with nuclear weapons. Enrico Fermi, Edward Teller, the father of the atomic bomb, the father of the hydrogen bomb. Now, we can argue whether these guys did the right thing by making those devices. There's many reasons why they did, and we can go around in circles for a long time. What you can't argue with is what happened next. They kept the scientists in the discussion. They didn't walk away from what they made, and they made sure that their tools never got used again, which is good, because we're all still here. And I think we're up against almost exactly the same thing. And Satya said this when he referenced 1984. Before he showed that demo, he talked about this dystopia. And I went looking for covers for 1984. Let me tell you, there's a bunch. And they say a lot about this challenge. This is arguably the definitive 20th century book. Now in the 21st century, we can make this come true, or we can stop it. We really do have a choice right now. As developers, we choose what happens next. And you think about what we've done with software lately, not all of us have made real good choices. If you haven't followed all of the insanity around Uber, and it's easy to, the misogyny and the bad culture, we can deal with all of that. For me, the one that chilled me was Grayball. So Grayball is a piece of code inside of the Uber app that manages to keep itself installed even if you uninstall Uber. It was designed initially to track drivers that were going to other driving services, but they eventually used it to hide from the various investigators that were looking at Uber. So if you were an authority in New York, they'd identify your phone and they wouldn't show you cars. It would identify that somebody in Cupertino was trying to test the app, and it would turn off all of its features to hide the fact that it was actually spying on people constantly. This is a stealthy piece of software, and I'm not all that worried about Trevor Kalanick. Admittedly, he's no longer there anymore, but CEOs are CEOs. What bothered me was the developer. Somebody wrote this thing. A group of people wrote this thing. And the only saving grace I have to the whole thing is that we know about this, right? That somebody made an Enrico Fermi or Edward Teller decision to leak the fact that this is what they asked us to write. And rather than turn away, I did it, but I need you to know. And of course, this is when Tim Cook went after Uber in a big way. It's like, you'll take this stuff out. This is evil software. There's no other way around it. And so as developers, we have to choose. We choose what we're going to do with this. I think everyone in this room in the next 18 to 24 months is going to be confronted with utilizing these new tools, these AI-related tools, whether it be vision systems or audio systems, and we're going to have to decide how we use it, what we're going to do with it. It's a moral gut check about the power that software represents today. We're going through a gate in civilization. We can make 1984 come true, or we can render ourselves immune to it. Right? We can choose whether or not we emphasize truth over deception, whether we empower just a few or everybody. That's where these tools are right now. So when you're thinking about development for the rest of this year and next, it's one thing for the tools we have right now, but the tools that are about to hit are going to make you think seriously about what matters to you. And when you have to make that choice, I hope you'll make us all proud. Thank you.